Welcome to this module on computer displays, focusing on the hardware topics in the CompTIA A+ exam. I'm Glenn Weddock, and I'll be your guide for this course on computer hardware. From laptops to desktops and printers, this course will teach you about the functioning of core hardware components, as well as repair and replacement techniques. Memory, cabling, storage, motherboards, power supplies, you name it, we discuss it. This first module starts us off with an exploration of computer displays, the different technologies, components, attributes, and standards that an aspiring IT technician is likely to encounter. And now, let's grab our computer toolkit and get to work. The unifying theme of this course, as we proceed from module to module, is the building of a typical modern desktop PC with the parts and pieces that we will discuss throughout the course. Many of the photos in each module are pictures of the components that will ultimately be assembled to create a functioning computer. The idea is to connect the subject matter to real life by showing how everything fits together. And with any luck, when we get to the end of the course, our do-it-yourself PC will actually boot up. Now, to help orient you as to the organization of this course, the topics we're going to cover include this module on the basics of computer displays, a discussion on the cables and connectors that allow computer components to talk with each other, a close look at PC memory, or RAM, which is where the currently executing program and data file lives, the various longer-term storage devices, which can remember programs and data even after the PC's power is shut down, the central circuit board, called the motherboard, along with the central processor and peripheral circuit boards that plug into the motherboard, and the magical power supply units that transform AC power into the types of DC power that computer components require. We'll wrap up with two modules dealing with printers. First, one on multifunction printers of the type usually found in office environments, and then we'll chat about the basics of maintaining printing devices, including single-function printers such as, for example, color inkjets. Now we'll begin with a look at common display types, which have become so advanced that they bear little resemblance to this beast of an old-school CRT display. This is the NEC Multisync that I used during the early years of my computer consulting business, even though it did seem very cool at the time. Now in this clip, we're going to focus on the main display technologies in use today, namely liquid crystal display, which has three varieties, including twisted pneumatic, in-plane switching, and vertical alignment, and light-emitting diode, which also has three main flavors: the original LED technology, the more advanced organic light-emitting diode, and the newest kind, the mini light-emitting diode. As you may know, today's computers often have more than one connector for interfacing to a high-resolution video interface. Here's a recent model laptop with two Thunderbolt ports and an HDMI connector. Now in this module, we're going to focus on the display hardware rather than the nuances of these different interfaces. So let's first turn our attention to the LCD display. The modern world is full of liquid crystal displays. The digital multimeter in the picture at left is one example. The technology involves, as you might have guessed, something called liquid crystals, a sort of intermediate state of matter between liquid and solid, discovered by an Austrian chemist in 1888. Liquid crystals can rotate the orientation of light waves under the influence of electric fields. When liquid crystals are placed between polarized glass panes, we can use an electric charge to tell the crystals whether to rotate light waves or not, effectively turning pixels on or off by either allowing light to pass between the polarized glass panes or by blocking it. Now, for this technique to work, we need backlighting, cold cathode fluorescent lamps, which run on AC power. Okay, well, how do we get color? Transparent films of red, green, and blue subpixels handle that duty, converting 3 subpixels into a single effective pixel with a specific hue. The online Encyclopedia Britannica has a good article on the physics, if you'd like to learn more. So, an LCD display with CCFL backlighting is usually just called an LCD display. There are 3 main types. A TN panel, or twisted pneumatic, gets the job done, but has limited viewing angles and the poorest color quality. However, it has a fast response time, so it can support high refresh rates, making it a quick display. It also has the virtue of being cheap. The IPS, or in-plane switching display, can be viewed from wider angles and has very good color, but it's also a slower display than TN, making it potentially less great for games with lots of motion. The VA, or vertical alignment LCD panel, exhibits the best aspects of TN and IPS displays It has the best contrast ratio, that is, the difference between light and dark, but a slower response time than TN. Now, I'd show you these differences here if I could, but they don't really come across via slides, although you can easily see the differences when looking at these displays in person. For the curious among you, TN displays twist the liquid crystals in a non-level plane. IPS rotate the crystals in a plane that is level and parallel with the display surface. And VA displays tilt the crystals in a plane perpendicular to the display surface. Now, LED displays differ from LCD displays in the backlighting method used. Specifically, the backlighting is generated by light-emitting diodes rather than a CCFL array. So, to be precise, an LED display is still really an LCD display, just with LED backlighting. Light-emitting diodes have been around for many years. You can see an example of a primitive LED display in the picture, and they are basically semiconductors that generate light when a current is applied to them, without simultaneously generating very much heat. LEDs use power more efficiently, and they typically last longer than CCFL arrays. LEDs also have the advantage of working with direct current, which is the kind of electricity that computers use natively for their other circuitry. Incidentally, you may see the acronym QLED for quantum LED in connection with the term quantum dots. These displays, pioneered by Samsung, use electrically excitable nanoparticles, and they modify the light from the LED backlight before that light strikes an LCD panel. QLED displays are normally brighter than other types, and may be a good choice for bright locations. Well, the third main type of laptop display uses a technology called OLED, short for Organic Light Emitting Diode. The OLED uses organic compounds, that is, carbon-based compounds, that emit light upon stimulation by an electric current. OLEDs have been around since the mid-2010s, and the great thing about OLED displays is that they don't need any backlighting at all, because the OLEDs generate their own light. That means that the display can be thinner because it doesn't need a CCFL. It also means that blacks are truly black and that colors in general are more accurate and don't suffer washout from the illumination layer. OLED displays are usually a little bit less bright than other LED displays, such as QLED. And a fun aspect of OLED displays is that they can be twisty and bendy. You may have seen foldable smartphones demonstrating this fact. Of course, all these attractive features come at a price, which explains why OLED displays are still more common in smaller devices like phones, smartwatches, and tablets. Now, we should also mention an interesting recent variant known as the Mini LED display. Here, several thousand LED backlights provide extra brightness and a greater degree of control over the displayed content. Which sounds great, but Mini LED displays still defer to OLED types in the areas of blackness depth, color range, and viewing angle requirements.